All right, CNT120, Chapter 1, we're on the section on the OSI model. Why are we going to discuss this? Okay, we need to figure out how data moves around a network. So let's start with, I think they use this example here. This shows, okay, this is how data moves on a network. Well, if you're like me, you look at that and you're like, okay, kind of. Let's relate real quickly. If we think about how we mail a letter or a piece of mail, if we follow the proper protocols of addressing it correctly, address here, return address there, stamp there, put it in the correct mailbox, put it in the correct, box. I don't want to put it in, just some random box anywhere, put the correct mailbox. The postal carriers will pick it up, read that. They can read that address to know, oh, it needs to go in this bin, so it goes to this city. Once it gets to that city, the people read and go, oh, it needs to go in this bin, so it goes on this truck. And then as it drives these streets, it goes, oh, here's the mailbox we need to put it in. They put it in the mailbox and close the door, and you get your mail, or the person you sent to gets your mail. As long as we follow that protocol, that procedure, I can get mail to just about anybody anywhere. Okay. Well, when we move data around, we need some way to describe that as well. We need to describe this process, what's going on. Well, the OSI model is a way to do that. The OSI model was developed in the 80s by the ISO, International Standardization Organization, as a way to say, hey, if we're going to move data around, here's the way we should be doing it. And it allowed manufacturers all over the world in all kinds of different countries to start developing things to do, oh, here's a network card that'll move data on and off. Here's a router that'll move data around. Here's a switch that'll move around. And it's actually doing the same function as other routers and switches or other network cards. That was a way for them to do that. They developed the layer model in 1977, and they actually developed two things. They developed the model, and they developed a series of protocols. Now, we don't use the protocols today because we use TCP/IP. We don't use the OSI protocols. We use TCP/IP. However, that model, this OSI model, is still hanging around because it's a good way to describe how data moves around a network. So this was created as a way to say, hey, if I'm going to develop a NIC, I develop to do these functions, but it's also a way for us to describe as data moves through these layers, what is happening. What is happening? This is a way for us to do that. So for us, we're going to study it because it allows us to take this complex topic of how does data move on a network and break it into easier, smaller pieces. Similar to if I ask a mechanic, hey, describe for me how a car works. That is too large. There's too much going on. But if I ask a mechanic, hey, can you describe to me how the shock absorber is working in my car to dampen my ride so it's not as bumpy? Oh, they can describe that. Or can you describe to me how the brakes are working? Oh, yeah, we have this disc and we have some calipers that come around and brake pads to squeeze to slow you down. Okay. They can describe a piece of it a lot easier. Same idea here. We'll be able to take this complex topic of networking, break it down into little pieces, and describe what's going on those various pieces. So this is going to create this common language that we need, and it's going to even help eventually with troubleshooting. I can start zeroing in on things on a certain layer to narrow down what's working or what's not working, or basically say, well, this is working, but this is not, and maybe narrow down what I'm looking for troubleshooting. It's going to build you this common vocabulary. As I always say, you're going to sit around the lunchroom and talk about the OSI model? No. However, as you work in IT, people kind of expect you to know it because of how things are occurring. And they'll write articles, or you'll read articles or read books that say, hey, when dealing with layer 4 security, hey, when dealing with layer 3 security. They're expecting you to kind of know what's happening there, to know that is your base knowledge so we can explain more of what's happening. Okay? So, with that in mind, here is a picture of the OSI model. I have a bunch of different pictures here. And this shows your layers 1 to 7. It is a 7-layer model. There is some mnemonics you can use to get the layer numbers in order, and that can be helpful. Here's another picture of the OSI model. Here's the OSI model layers here, and OSI model layers here as well. So I have a couple different options here, whatever kind of seems to work for you. If I look here, I have the layers spelled out for it, and you notice I purposely have 7 up top, 1 at the bottom. Think of this as like floors in a building. If I pull the first floor out of a building, it's going to fall. So layer 1, everything sits on top of layer 1 in my network. That's why it's listed at the bottom. So we have the application for 7, presentation for 6, session for 5, transport for 4, network for 3, data link for 2, physical layer for layer 1. And we're going to start describing what these are and what's involved there. Here is mnemonic 1 you could use to maybe get your layers in order. All people seem to need data processing. That'll get them 7 to 1 for you if you want to go top down. If you want to go bottom up, here's another mnemonic. Please do not throw sausage pizza away. And if you're a vegetarian, you can make that spinach pizza. Please do not throw spinach pizza away if that's helpful to you as well. This is the one that worked for me because I could get them 1 to 7. Please do not throw sausage pizza away, or please do not throw spinach pizza away. That'll get the layers in 1 to 7 for you. That's the first step. Get that tackled first. And if I look here, P for please for physical, D, do for data link, N for not, network, and so forth. That'll get those layer names in order. The next thing will be to get the functions. And that's what we're going to go through kind of piece by piece here. All right. All right, so here's my layers. I'm going to start up here at the application layer because I'm going to kind of approach it. Let me slide back here with this in mind. We're going to get something ready to send it through a network and then on the other end receive it. So I'm starting at the top up here, kind of writing my letter, if you will. So I'm going to start up here at layer 7 with the application layer. All right. Application layer, we're talking about the applications. We're not talking about Microsoft Word or Microsoft Excel. We're talking about the applications that are going on behind the scenes like we talked about earlier this chapter. Things like HTTP, things like FTP, things that without a network are kind of useless. My browser on my computer is kind of useless without a network or network connection, kind of. So we're talking about those applications that are going on in the background. So, on the application layer, I'm talking about this application on my computer, maybe HTTP or SNMP or SMTP, that is going to communicate with another entity elsewhere. So I'm looking at things like this right here, HTTP, FTP, email, network management protocol. I'm looking at those applications that are going on behind the scenes. My browser uses HTTP and HTTPS. My email application uses SMTP, POP3, and IMAP4. I'm looking at these network applications. Okay. So when I want to load a web page, I'm going to be using HTTP. And I think I have it up here. I'm using one of these like HTTP, one of these protocols up here. That is the application layer that we're talking about. Those applications. Things that are kind of useless without a network. My presentation layer, okay, so up top here, maybe I open my browser to browse for a web page or send an email. Well, now at the presentation layer, we have to get it formatted in a way that the other computer will understand. So the presentation layer is all about that. How do I get this formatted in the correct way that the receiving computer understands I want the web page, or the receiving computer understands this is an email? So this is the layer that's responsible for doing those things. If I need to compress it for compression's sake or encrypt it, I would do that. But I might just need to format in a certain way so the other computer understands. Okay. And I think I have right here. Think about this. If you and I have emailed, or you've emailed, another person, when you sent the email, did you think about, hey, I wonder what email application the other computer is using? No, because, in reality, I don't really care, because I know, I might not know this, but deep down I know that when my email is sent, it's put in a format like HTML or TXT that the other computer will be able to open and answer. That's what my email application is doing. It's putting in that common format so that the other computer can open it, read it, and respond to it. That is what your presentation layer is all about. If I'm going to send an email, the email application is going to get it in HTML format so the other end can read it. If I'm going to load a web page, again, I need an HTML file so that the computer can read it. If I'm going to send a picture, JPEG. If I'm going to send a video file, MPEG, okay? Those kind of things. We need to be in that common format so the other end can open and view. Here's some compression examples. Here's some encryption examples. So my presentation layer needs to get in one of these formats so the other end can open and view correctly, which is why when we think earlier about sending emails back and forth, you didn't think about what I'm using, and I don't think about what you're using, because we know the email, deep down we know the email application is putting it in a format that the other computer will understand. That's your presentation layer. Layer 5. All right, this is a little tougher. A lot of books like to try to want to combine this with other layers, but your session layer is kind of like the communication manager, looking out for the session, making sure it gets set up, maintained, shut down kind of thing. So here, this is kind of like your traffic controller, making sure that the session is set up, we communicate, it's maintained, and when we're done, it's closed down correctly. And I think the book in here uses like keeping a Zoom session active, or if you're logged into a bank or something, it'll keep that active. As long as I'm doing activity on there, it keeps that session open. But if I sit idle for a while, it's like, okay, I'm going to sign you out. That's kind of evidence of what is happening at your session layer. Transportation layer. Okay. My transportation layer is where my data starts getting a little more important. Up until now, we had the data, we got it in the right format, and now we're going to send it. Well, the transport layer is going to do some various functions depending on what I'm doing. It could use either TCP or UDP depending on what I'm trying to do. And again, this is going to choose for me. I don't have a choice. It's going to do it for me based on what I'm trying to do. Well, here's what I mean. If I'm going to send, maybe I'm going to send a email. If I'm going to send an email to you or a file to you, I need to make sure all of it gets there. Because if a partial email gets to you, it's not very usable. If a partial file gets to you, it's not very usable. If a partial web page gets to you, it's not very usable. And I always use the email example. If I send you an email that says, meet you at 5, and that's where I have a detailed message, but only that part gets to you, I'll meet you at 5. You'll be like, 5 o'clock a.m., 5 o'clock p.m., 5 o'clock on what day, what location, only part of the message got there, it's not very useful. Well, TCP is the protocol that's going to make sure with these kind of applications that all of it gets there. And what it's going to do is it's going to take that message, break it into pieces, number them all, and keep track of all of them. And make sure all the pieces get there. Here's an example of the kinds of protocols that use TCP. Things like your email, things like your web page, things like a file transfer are all going to use TCP. And TCP, again, is going to label everything, number everything, and make sure it gets there. If a piece goes missing, TCP is going to try to ask for it again and make sure it gets there. That way you get all of your file. That way you get all of your email. That way you get all of your web page. We'll talk about TCP more in Chapter 4 on how it's doing that. But that is what's happening at Layer 4. The other thing that can happen at Layer 4 is your buddy, your pal UDP might get used. Well, if I'm sending a voice traffic or video traffic, maybe a phone call or Zoom stream kind of thing, I don't want all of that double checking to make sure it gets there because it's going to slow my conversation down. And I might literally have pauses in my conversation. So what gets used instead is UDP. And UDP cuts out that extra overhead and just kind of almost acts like a traffic cop flagging everybody through. Keep moving, keep moving, keep moving, keep moving. It puts enough of address in there that it just gets it going to the destination. If a couple frames of video or a couple frames of audio are missing, we usually don't even notice it. So we'd rather get it there, maybe missing a little bit, but rather get it there timely than worry about missing a couple frames or a couple, little blips of audio. So that is what's happening at Layer 4 to make sure all of my data gets there, or all of my data, if I'm doing like voice or video, is getting there quickly. That is what's happening at Layer 4. Now, when we come back, we're going to start talking about this data encapsulation process.